why are room temperature superconductors a big deal? Why was it a big thing? What problems does room temperature superconductivity actually solve? And what are the complexities in making a room temperature superconductor? So, what's a superconductor? Hmm? A superconductor or a superconducting material is something that allows electricity to flow with zero resistance, which means that no energy is lost in the form of heat during transmission. If you take copper wires, they're an excellent conductor of electricity, but there is some loss, maybe 10-15% loss, maybe 5%, 10% loss. See, right now, we have an electrical grid and all this current everywhere around the world, more or less, it goes through copper wires of various kinds, and you typically lose 5 to 10% of the electricity that's generated during transmission in the form of heat because of the inherent resistance of the copper of copper as a material. Everything has some resistance. Now a superconducting material is a material that has zero resistance, so you don't lose anything. But the problem is that you can't do that at room temperature. Okay, so that's why room temperature superconductivity is one of the so-called holy grails in physics and material science, right? So essentially, if you have that, then you can have electricity being you can transmit electricity without losing any of it in the form of heat. Okay, so if you have room temperature superconductivity, then power distribution would be way more efficient and way more economical. Now, it's not just about power transmission. There's many other technologies that you could that could be transformed if you have room temperature superconductors. For example, MRI machines. Today's MRI machines, they need liquid helium for cooling. So if you don't need that cooling anymore, it will become way more powerful and way more efficient and way cheaper MRI machines. Then you can have magnetically levitated trains that are cheaper, much cheaper to operate. More powerful and more compact electric motors and generators. These days quantum computing has become a big thing. Have you seen the quantum computers with this gigantic apparatus? Much of it is the cooling mechanism. So if you don't need complex cooling systems anymore because of superconductivity, then it will be a revolutionary step forward in quantum computing, and so on and so forth. I can give you so many other examples. So, but the deal is that superconductivity doesn't work at room temperature. It's extremely difficult to have superconductors work at temperature. And why is it so? To understand why it's so, you to understand how superconductivity works. So, to give you a very brief overview, superconductivity relies on pairs of electrons called Cooper pairs moving together in a material in a coordinated way. Now, if the material has a certain temperature, higher temperature, then thermal vibrations in the material will break up the Cooper pairs, and then you won't have superconductivity. So, to get a material to maintain this delicate quantum state, you need to cool it significantly, significantly below room temperature. And to have this phenomenon happen at room temperature, you need extremely precisely engineered crystal structures and electron behaviors. So that's the challenge. So right now, currently, the challenges that we face towards superconductivity is that most materials that are promising superconductor candidates, they are unstable at room temperature, or they degrade very rapidly. And some so-called room temperature superconductors only work under extreme pressures. So it's room temperature, but it's under tremendous pressure, and it's very difficult to you need a material at a certain amount of purity, extremely high level of purity, and a very specific kind of crystal structure. And to manufacture that is extremely challenging. And many so-called high temperature superconductors, they can only carry small amounts of current before losing their superconducting properties. So these are the challenges that we are facing, and that's why you don't have room temperature superconductors. Recently, there was this claim of this exotic material, right, called LK99 or something. It generated a lot of attention, but eventually it was not. It We could not verify it as a genuine room temperature superconductor. These are the challenges. But if we can crack the problem and we can have a genuinely successful room temperature superconductor, it would completely revolutionize so many different fields. So that's superconductivity. And you may have heard of semiconductors, right? I mean, in phones, in computers, everywhere we use semiconductors. So semiconductors are dual use kind of materials. Uh, in the absence of an electrical current, they don't conduct. Uh, they don't conduct electricity, but if you apply a current or a voltage or something, they will conduct electricity. So they can act as gates. And that's why you have the AND gates, OR gates, NOR gates, and so on and so forth in transistors and semiconductor conductor chips. Anyhow, so that's the deal with room temperature superconductors.